Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about Bluetooth. So this is the famous wireless communication technologies that will be used in day-to-day life. So if you take an speakers, that is if you take a headphones, again if you take a mouses, keyboards, so many things we use this Bluetooths. Even if you take a speaker, we have a Bluetooth speakers. Look at this. The name Bluetooth was named in the 10th century. So this is the Denmark Harvard Bluetooth. So actually his name is only we taken as a Bluetooth for the devices. He only identified this and developed these devices. This name was adopted because Bluetooth wireless technology is expected to unify the telecommunication with the computing industries. Look at this. This is a symbol of Bluetooth. So Bluetooth is an open standard for a short-range digital radio interconnections for a variety of devices like cell phones, PDA, notebook computers, modems, cordless phones, pages, laptop computers, printers, cameras. So this is some of the examples. We can use this for speakers, headphones, mouses, keyboards. So these things will be we can communicate with the Bluetooth. So by developing a single chip, low cost radio based wireless communication technology, so this can be possible. Look at this, how the Bluetooth works. Look at this. We have one device, this is called a master. So remaining all devices that can communicate, that will have a, we can take it as a slaves. So if you take a one network, so only one master can be allowed, so remaining all can act as a slaves. Again, the same system cannot work a master for another devices. Okay, but if you take a slave, same slave can be connected with the two masters. Look at this. This is the one network. This slave is connected to this master. Similarly, for the another network, this slave is connected to this master also. So slave can connect with multiple master, but master can be only one device. That cannot be another master. But if you take a master, it can be slave for another device. That will be possible things. Look at this. This is the Piconet A. This is we take is the network, that is the Piconet B. Look at this. So between this will be act as a master for these three devices with this master, and this is the master. It can serve for a communication between these devices. We can have a mobile phones. Again we have a printers. Again we have a pages. We have some toys. We may have a cameras. So many devices. Look at this. This is one network and this is another network. We have a master and slave devices. Here also we have. Look at this. This device B that can communicate with this both masters. When more than two Bluetooth devices communicate with one another, we can call this as a Piconet. P-A-C-O-N-E-T. That is a Pico network. So this can be contained up to 7 slaves clustered around the single masters. This device that can initialize and establish the Piconet becomes the master. Who establishes the communication, that becomes a master. Anytime we can change the masters also. This master is responsible for a transmission control because multiple data can be transmitted the same channel. So this will be avoided by the master. So complete control will be under the master device. So this will be have a network and then establish a communication. It allows the time slots among the members to share the channels. So we use this time division multiplexing scheme to communicate this. For example, if you have a printer that will be shared within two devices, so one device can use at a time. So after completing only it will be allowed for this. So we allot a time. So for 5 minutes it will be for one system, and another 5 minutes will be another system. Like that, time division multiplexing concept will be applied. So each shared system can be, for example, if you take a printer, shared printer can be combined for multiple devices. So this is a simplified communication between the device and an internet or a data synchronization. It will operate a licensed XM this ISM band. The frequency supports will be 2.4 GHz. Uses the frequency hopping spread spectrum concepts. This is an omnidirectional. Again, there is no need of line of sight communication is required. So line of sight means the both transmitters should be in the straight line. But here there is no line of sight communication is required. Again, Bluetooth offers a data speed up to 1 megabytes per second up to the range of 10 meters. So it will be supports the up to 10 meters. Unlike IRDA, the Bluetooth supports the LAN like an mode where the multiple devices can interact with each other. So there is no need of one-to-one. So we can have multiple devices, it can communicate each other by using this Bluetooth. The key limitation of Bluetooth are security and interference with the wireless LANs. This is the limitation available in a Bluetooth. Again, short range wireless radio frequency will be used in Bluetooth. Again, Bluetooth and PAN technologies, that is a personal area network technology. It offers a fast, reliable transmission between the voice and data. It can support either one asynchronous data channel with up to 3 simultaneous synchronous speech channels, or one channel that can transfer asynchronous data and synchronous speech simultaneously. It supports both packet switching and circuit switching. So node to node, it can establish a packet switching methods or circuit switching methods. Both will be possible. Again, this Bluetooth PAN, it will be standard for it eliminates the wire and cables between the devices. So automatically we can establish a communication with the movable devices like a mobile devices or any other devices. There is no wire should be connected. So automatically without wire connection we can establish a communication. Again, facilitate both data and voice communication. So the communicate between transmitter and receiver may be a data communication or voice communication also it supports. It offers a possibility of ad hoc networking and deliver a synchronization between the personal devices. Again, Bluetooth enables that devices can automatically locate each other. So whenever any one device comes within that Bluetooth range, it automatically detects and it can establish a communication. The topology is established on a temporary and random basis. So depending upon the number of nodes, the random basis, any topologies can be like a star or any topologies can be established. Upon the 8 Bluetooth devices may have a network together in a master-slave relationship in the Piconet. That it have a maximum 8 devices, 1 master and 7 slaves. One is a master which controls the setup of the networks. All other devices operates on the same channel, follow the same frequency hopping concept. If you take a one network, within the network all 8 devices must use the same frequency hopping technologies. 2 or more Piconet interconnects for a scatter net. For example, the one device slave can be connect with the 2 masters. Only one master for each Piconet. More than one master is not possible. A device cannot be a master for 2 Piconets. So master with only one Piconet. Again, the slave can be a one Piconet can be a master for another Piconet will be possible. That is, a slave of this Piconet network can be act as a master for another network. It has a set of an ISM, that is an industrial, scientific and medicals. So for an executive Bluetooth, look at this. This is the frequency range, 2.45 gigahertz. So communicates at the 2.45 gigahertz for the Bluetooths. Simplified Bluetooth stack. Look at this. This is an ISO OSI layer. It supports this physical and data link layer. Look at this concept. Bluetooth stack. We have this application or profiles for the protocols. We have the TCS control, SDP, others, and then RF communication. We use this L2 cap data link manager. We have this SEO and acknowledgements. So this is the Bluetooth baseband and this is the Bluetooth radio frequencies. So this is the actual simplified Bluetooth stack data. Thank you.